In the previous video, we have seen dispersion without deviation. Now we will see deviation without dispersion by suitable combination of suitable combination of prism. We can bring deviation. We can get deviation without dispersion and dispersion without deviation. It means net deviation will be 0, and we can get dispersion, and we can get net dispersion is equal to 0 with deviation. It means this is the refractive index of the first prism, refractive index of the second prism, angle of prism for the first one, this is angle of prism for the second one, this is angle of incidence after refraction. It will go like this, this is the, and further we will get like this. This is red, yellow, and violet. So there is certain angle of deviation with the incident ray and the incident ray and the refracted ray. So since this is deviation without dispersion, it means net dispersion. Theta is the net dispersion. This net dispersion is equal to dispersion produced by the angular dispersion. Dispersion produced by the first one and dispersion produced by the second prism is equal to 0. That is, it's equal to 0. As it is, we have seen theta is equal to rho of theta is equal to rho of V minus R for the first one plus rho dash V minus dash R, which is equal to 0. It means this is equal to 0. This is equal to mu V minus mu R into A for the first one plus A into mu R for the first one plus mu dash V minus mu dash R into A dash for the second one. A dash R for the second one. In that case, we can calculate A dash. What is A dash? A dash is equal to, this we take it other side, minus mu V minus mu R into A divided by mu dash V minus mu dash R. This is the calculation of it. This minus calculation for the refractive angle for the refractive angle of prism for the second one is A dash, which is given by in terms of the refractive index. So we take the mean deviation with respect to the yellow light. The mean deviation with respect to yellow light. Why? Because the yellow is the counted as the mean of the angle of deviation for this spectrum, for this dispersion. Dm is equal to mu of y minus 1 into A in general expression. With net dispersion, D is equal to 0. We got angular prism of the second one is equal to minus uv minus u violet minus red into E divided by u dash v minus u dash r for the second prism. This minus indicates what? This minus indicates that the two position of the prism must be put in reverse way. That is, the angle of prism of first one and angle of prism of the second one should be oppositely placed. So net dispersion is equal to 0, we got this A dash value is equal to this much, and dispersive power is equal to, already we have derived dispersive power is equal to mu omega minus violet minus mu red divided by yellow minus 1. So now without dispersion we got this result. And deviation, what about deviation? Net deviation is equal to 1 plus deviation produced by the first one plus deviation produced by the second one. So and deviation is equal to 1 plus 2, this is equal to mu of y minus 1 into A plus mu dash of yellow minus 1 into A dash. Putting the value of A dash from this expression, O is equal to mu of y minus 1 into A plus mu dash of y minus 1 into A dash. A dash is equal to minus refractive index minus of refractive index of violet minus refractive index of red multiplied by A divided by refractive index of second one minus refractive index of violet minus refractive index of red into E, and complete this one. So we can take the E outside since it is common, is equal to refractive index of yellow minus 1 plus E is out, refractive index of second one, this is for second one, and this plus into minus will become minus into refractive index of violet minus refractive index of red divided by this, we can take it here, mu dash V minus mu dash R. Since we have given this is V minus R, refractive index of V minus R, the refractive is yellow minus 1 is equal to dispersive power. This is in the reverse form, that's why we can write A into mu of y minus 1 by dash, because this portion indicates 1 by dispersive power of the second prism into V minus mu r. So we can write this way. Again, if you take mu y outside, if you take it outside, mu y minus 1, this one outside, this is equal to E into mu of y minus 1. Here 1 will be left minus. Here we have to divide by, since we have taken out, we have to divide this portion by mu y minus 1. 1 by omega dash into mu of V minus mu of R divided by mu of y minus 1. This completes the equation. When you take it inside, this will come here. When you take it inside this one, this will get cancelled. So this is equal to A into mu of y minus 1 into minus 1 by 1 by omega dash. This is represents what? This represents the dispersive power of the first one into omega. So we can write it, the deviation produced, net deviation produced is equal to this much, which we can write net deviation produced is equal to A into refractive index of yellow minus 1 into 1 minus omega divided by omega dash. This is the expression. Therefore, if the refractive angle of two prisms are different and refractive index of two prisms are different, we can produce both, that is deviation without dispersion and dispersion without deviation. That is, if deviation without deviation without dispersion without deviation, that is deviation is equal to 0. In that case, we get the result dispersion without deviation, dispersion without deviation. In that case, we get first deviation is equal to 0 and dispersion is equal to mu of y minus 1 into angle of prism of the first one into dispersive power of first minus dispersive power of second. Second case, if deviation without dispersion, that is deviation is equal to dispersion is equal to 0, dispersion is equal to 0 and deviation is equal to mu of y minus 1 into a, both the part are same, only thing here 1 minus omega divided by omega dash. This is only for two prism with both the prism materials should be different. In that case only we can produce deviation without dispersion and dispersion without deviation. However, if you are having both the prisms of the same material, it means both are having same angle of prism and angle of refraction. In that case, we can produce it like this. Incident ray, it refracted like this. This is red and this is violet. After passing it through the another lens, kept in the reverse, and it will go like this. Then afterwards, it gets and it goes. It can be caught in the screen. This is happening when both are having angle of prism same and both are having refractive index same. In that case, we will not get deviation as well as dispersion, because single ray goes after dispersion, we are getting single ray. There is no question of where this is the angle of incidence, along the angle of incidence it goes. Therefore, there is no possibility of dispersion and angle of deviation if the prism materials is same. That is, angle of prism of both the materials same and refractive index of the both the materials same. It means both the prism materials should be same.